Hi, it's Mr. Duffy. In this video, I'm going to be doing the first problem on your worksheet of the vertical motion projectile problems that are just a little bit more difficult. These problems are just a little bit more difficult because they might ask for something a little bit different from a lot of the other problems we've solved. In this first one, what we've got is we've got a individual throwing an object vertically, and it doesn't come back down. So just the upward portion of a motion. We don't normally do that. We normally solve for the upward and downwards portion, but again, that's something we could do. So let's go ahead and take a look at this problem and see how we can solve it. So it says a lovesick lad wants to throw a bag of candy and love notes into an open window of his girlfriend's bedroom 10 meters above. Assuming it just reaches the window, which would mean it just gets to the highest point in its motion, he throws the gifts at a 60-degree angle to the ground. What velocity does he need to throw them? I'll draw myself a little diagram. We get ourselves a 60-degree angle from the ground, and we want to figure out the hypotenuse of that triangle, which means we're going to have to solve for the velocity in the x and the velocity in the y to be able to solve for it. Now, we don't really have any of those velocities. All we have is an angle, but we have a distance vertically. We know that it's going to go up 10 meters. Now, that really kind of sets the key as to what we need to do to solve the problem. It's going to amount to how much time is it going to take for the bag of candy to get to the top of its motion. Okay, how much time is it going to take to get there? And a lot of our projectile motions revolve around time. In this problem, we have our distance, and what we're going to use to solve this is velocity initial times time plus half gt squared. Now, the distance that it's going to move is 10 meters as it goes up to the window. And the half of gt squared, we know that g is negative 9.81, or whatever, positive if we ignored it, but it is negative 9.81. And then that leaves the velocity initial times time. Now, what we need to kind of do to kind of realize and solve for this one is, we don't have an initial velocity. But what we need to imagine is that it doesn't really matter. What would happen is if that object was able to fall back down, it says assuming it just reaches the window, that's its highest point, assuming that it just reaches the window and maybe was able to fall back down, then in that case, the initial velocity as it fell back down would be 0. And so that's going to allow us to cancel out that portion of the motion there and ignore it, and allow us to solve for the time. Now, again, we just kind of have to think about the problem in a little bit different way to be able to solve it for the time. That leaves just the time as our one variable, and so we have negative 10 equals negative 4.905 t squared. Divide 4.905 to the other side, you get t squared equaling, see, it should be about 2, right? So 10 divided by 4.905 is 2.04, and we're going to square root that. It's going to be in the air for 1.4 seconds. Okay, now if it's in the air for 1.4 seconds, then that's going to allow us to solve for how fast it was going in the y direction. So the velocity final equals the velocity initial plus acceleration times time. Again, the last problem we used displacement. Now we're really trying to find velocities. So the velocity final when it reaches the top of its motion is going to be 0. It's going to, again, reach the top of its motion. It's going to stop. Acceleration is going to be negative 9.81, and the time we know is 1.4 seconds. So let's go ahead and figure that out. The velocity comes out to be 14 meters per second. Now that's the vertical velocity. That's the velocity in the y. So I'm going to change that. I'm going to erase that over here on my diagram. That is 14 is the y direction. Okay. Now, You'll notice to solve this first part for part A, I have an angle and I have a side, and so I can just use a trig function to solve for the hypotenuse, in which case that would be sine of 60 degrees equals my opposite, which is 14 over the hypotenuse. I'm going to also call it h. So we're going to do 14 divided by the sine of 60. That gives us a hypotenuse of 16 meters per second, 16.2. And that would be how fast a boy needs to throw the bag to get it into the window. Okay, so there's your first part. For the second part, we need to figure out how far away from the house is the boy standing when he throws the bag. So again, we need to figure out the distance that he's standing. Distance that he is standing is equal to the velocity in the x direction times time. We already know that the time going up would be the same as the time going down. So the time going up is 1.4 seconds. So the time going to the side would be 1.4 seconds as well. We don't know the velocity in the x. Okay, with that being said, though, we do know all the other sides. So if we know the hypotenuse is 16.2, and then the opposite side was 14, we can use the Pythagorean theorem, since it's a right triangle, to solve for the other side. So 14 squared plus b squared equals 16.2 squared. Just using that information from the previous problem. Okay, you get a velocity in the x direction of 8. So if our velocity in the x direction is 8, then 8 times 1.4 seconds is 11.3 meters from the side of the house. Okay, so again, a slightly different type of problem because we're just looking at upwards motion, but again, still something that I think we should be able to do as we're, again, working through some more of these vertically launched projectile type of problems. So you have questions 2 and 3 to do. If you have any questions, please send me an email. Thank you for watching.